All right, system security architecture. We looked at the enterprise from a holistic standpoint. We're going to look at systems from a granular standpoint. Looking at how do you design those services to be consistent and standard across services that literally aren't. Different kinds of platforms in different environments. Mainframes and thin clients where all the processing is done from a centralized location. Anyone worked in that environment before? Why would you want to do that? If we have PCs and they're as powerful as they are, why in the world would you ever go back to thin clients? Can anyone think of an environment where thin clients are used on a regular basis?
Point-of-sale terminals.
Point-of-sale terminals. Why? Why are those thin clients? Well, why are you shortchanging your user in that fashion?
You don't want them to have all that power.
Heck no. Not when they're, checking out gum and cigarettes, right?
There has to be a dedicated machine for that.
Good. They shouldn't have access to that capacity, right? The library was that way for a long time, where when they first ported the card catalog to an electronic format, it was all thin clients. All you could do was look up books according to certain search criteria. You didn't have the computing capacity of the computer itself. In certain classified environments, I've seen thin clients put into place because you don't want people processing classified information on local storage. That becomes one more point of failure. You are putting all your eggs in one basket if it's centralized processing, but you can protect that one thing, you can harden that one thing, and it's easier to guard one thing than many distributed things. Otherwise, you can have a distributed system. Why would you want a distributed system? Power to the people. Why do we want a distributed system?
Increase your processing power?
Yeah, absolutely. Gives the users more capability to do whatever it is they're supposed to be doing, right? Increase the functionality at every seat. Good. What's middleware? What does middleware do?
Stuff in the middle.
Stuff in the middle. It wears on the middle. Yes, it does. It's designed to assist in interoperability between systems and smooth out connectivity issues. Useful. Embedded systems. What's an embedded system? Limited standalone, often used for mobile devices. It's self-contained. It does everything it should right there in the box. Other mobiles, pervasive computing and mobile computing devices. That's the portable stuff. This is stuff you carry with you. In certain environments, have business entities gone wholly over to pervasive computing models? And why in the world would you want to do that? Everybody's walking around with all the business functionality in their hands.
Restaurants are doing it for taking orders and seating people. And
it's so much more cost-effective in terms of time than going back to that single centralized location and ringing up your orders there, right? It allows speed and connectivity with the kitchen as well. Good. I didn't think of that example. That's a really good example.
Nordstrom's also does it, checking you out. You don't have to go to a cash register anymore. An associate will come up to you and they'll check you out right where you are.
That's so awesome. Oh,
great chance for fraud right there.
Why do you think he thinks it's so awesome?
I'm going shopping before I go home. We don't have Nordstrom's in Sacramento. That's cool. I like that. Las Vegas, they do that in a lot of their cashiers, the change operators. When they walk around, they have a PDA with a wireless connected to their belt. I've seen cops who have that. Nevada Highway Patrol does that. On their motorcycles, they have a printer in the saddle bag. So when they write up somebody, they do it all on a digital input device, and then it prints the ticket out right there on the motorcycle.
You sound like you're speaking from experience.
It wasn't me getting the ticket. It wasn't. I promise. I would fess up. I would own my tickets.
He was the one getting arrested.
Yeah, I was not. Why would you think that of me?
He's the one frying the cops' donuts on the other side of the saddlebag.
Now, actually, it was very funny. I was a witness, and this young lady had gotten rear-ended by a drunk driver, and I was giving a statement. and the cop was writing up a ticket to her for having expired tags. I mean, insult to injury. I don't want to downplay our law enforcement friends, but man, that's just cold-blooded, you know? She had a gash on her head and everything. She's sitting there, her car's all mashed up. And I was impressed with the technology. I'm asking him about the PDA, and he's looking at me like I'm crazy. But yeah. He didn't arrest me that time. Databases. We talked a lot about these in earlier modules. These are collections, aggregations of data that can be used to create analysis and discover relationships between data that may not normally have been apparent if it was just in a list or in a memory dump. It's vulnerable to inference and aggregation, even though you can limit the perspectives that users can have. It is susceptible to prediction based on what is visible. There are web-based computing platforms. According to XML standards or using SAML, which is an XML-based standard, and it's got all these different vulnerabilities. If web-based systems are so vulnerable, if we have all these problems with them, why do we use them?
Because they're easy.
They're easy for who?
The end user.
Yeah. Well, are they easy for the administrator?
Well, no.
No. They're easy for the users. The users like them a lot, right? They're very intuitive, they're simple, they're straightforward. They allow them to do the work they can in a much more distributed environment. Again, those trade-offs. Okay. All systems, no matter what kind, have certain common components to them. These are them. We're going to go through each of them in turn. A processor, CPU, is the heart or the brain of the system. It's where all the calculations take place. And it should be the hardware component that's controlling the other hardware components. It's got these four main tasks associated with it. Processors should have certain functionality with them. Mind your way? Processors should have certain functionality with them. Multitasking, be able to go from one process to another in rapid fashion, allowing you to actually harness the power of the processor. Instead of staying with one process, you can multitask. Multiprocessing, add more processors so you have some load balancing and you can actually speed up again. Threads. Those are just a series of instructions going to the processor, and each thread's going to run for a limited time in multi-threading. Each thread gets to pretend like it's got exclusive access to that CPU, even though you might actually be multitasking. Memory and storage. Difference between primary and secondary. Difference between primary and secondary.
Temporary and permanent?
Temporary and permanent. Very good. Primary is the RAM. It's SD-RAM, ROM. Most of the time, it's not there once you turn the system off, except in the case of ROM. Secondary storage is comprised of what kind of hardware?
Hard drives.
Hard drives, removable media. Anyone remember Colorado backup disks?
Never heard of it.
No. Zip disks.
Okay, those are.
Zip disks. Yeah. You remember those?
Oh, yeah. I had a zip drive. Had a jazz drive.
A jazz drive. Cool. Very cool. Very cool. Those are.
I thought that was just another word for a USB stick.
No, honestly, and that's a really good point. I think we've morphed the meaning into that. No, zip disks used to be like this big. They were thick. They were about like 4 times the thickness of a floppy, and they had their own external drive. A lot of times it was it serial? Was it parallel port?
Depending on what year you bought it.
Was it parallel?
Parallel.
It was parallel, yeah. Eventually they turned into USB, but by that point, you had USB memory, so
At that point,
what was the
100 meg was nothing.
Oh, but 100 meg at the time, man, that was huge, huge. Wow. Yeah. Yeah.
I think some of them were built into the system too.
Yes, yeah. I actually, I had a girlfriend who had a zip drive in her PC, and that was like state of the art. She was a graphic designer, so she needed all that extra.
That's why you were
memory.
dating her, right?
I dig a chick with a lot of memory. What can I tell you?
Can you see her just like...
It's the easiest way to my heart. I could play more games on her machine. Virtual memory, secondary treated like primary. What's the risk there?
I've never heard of
What's the problem there? What's the detriment? Slow. Slows it down because you're hogging up. You're using more than your allotted primary resources. Firmware, kind of in between hardware and software. It's the instructions stored in the ROM, and you can sometimes it can be flashed in, and it can be reformatted. Different forms of memory protection. Processor states. There are two different states, supervisor and problem state. What's problem state? I love this term.
It's crashing.
No, you would think so. You would think so by the definition, but it's smarter than that. User state. User state is the problem state. It's a way of, again, controlling access, controlling permissions. And layering is, of course, assigning permissions based on classification levels. Data hiding is doing what? How do you hide data?
Make it look like it doesn't exist.
Good. In some cases, it has to do with another form of permissions where it's the read permission. And sometimes it's also encryption. Encryption is another way to do it. Peripherals. Peripherals. These are the things that we use as input-output devices. People can actually use them. Name a few.
Mouse.
Mouse is a good one.
Keyboard.
Keyboard.
External hard drive. External hard drive.
External hard drive. Good.
Monitors.
Huh?
Monitors.
Monitor. Monitor is kind of a peripheral, isn't it? Yeah. Have you ever used a computer that didn't have a monitor?
Yes.
They exist. Like what kind?
Most of the servers I deal with.
Oh, okay. All right.
Yeah.
Good. Anyone remember light pens? That was going to be the wave of the future, right?
Talking about the QCats?
Yeah, I had one of those.
Oh, yeah.
No. What was a
did.
QCat?
QCat was a little barcode reader that...
It was in the shape of a cat and the end was red.
Yeah.
That's cool.
I totally remember that.
And they used to put the little QCat... This has happened for all of like 2 years before they went out of business. Horribly. CUE cat.
CUE cat.
Yeah. And there were just these little angled barcodes that you could read. They appeared in tech magazines, and that was about it.
Oh, so it was like a precursor to the digital
QR
blots now?
Yeah.
That's cool.
That was when we were like junior high or high school.
Yeah, pretty close.
Did they work well?
No.
No, they're terrible.
Yeah, you had to scan those
You were
things like
like-
40 or 50 times. It was
okay.
bad.
Good. That's very cool. No, I was thinking, sorry, probably before you were in junior high, light pens you were supposed to be able to write on the screen, or you could touch objects on the screen and activate them. Anybody remember what the problem with those was? You needed another form of input in addition to the pen, which was like, it diminished the whole point of having the pen. So if you have to have one hand on the keyboard and one hand on the light pen, you can just go to the mouse, which is one-handed. Good. I want to look up that QCat thing, though, too. That's pretty cool. Was it USB?
Yeah.
And nobody adopted it in terms of the barcodes or anything like that?
It's a very, very small adoption rate. Even though they were handing the QCats out for free or for very little.
It's drivers. Drivers allow the OS to talk to the peripheral so that they can run.
Do we?
Different ports allow you to set up different peripherals as well. Nowadays, very popular ones are USB and mini USB. Don't see so many serial and parallel port connectors anymore. Huh?
Not even FireWire.
Not even FireWire. It never really caught on, did it? USB 2.0 is like the current and niftiest. I even had a machine that could do infrared for a while, and I thought that would be kind of cool. And I think Bluetooth even kind of fell behind too. Bluetooth isn't as popular.
It's been delegated to just headsets.
Yeah,
pretty much.
it's like strictly headsets, right? Yeah, I don't know why that is.
My guess would be the frequency hopping.
Too complex, or
Yeah, probably.
all right. The OS. It's the software that talks between the hardware and the software. It manages the file systems, and it's how the user interfaces with the system. Security capabilities for an OS. We talked about the kernel. This comprises what part of what TC-SEC established? What do we call this?
Trusted computing base.
Good. TCB. Good. Not taking care of business, but trusted computing base. Good. Trusted platform module. It's a chip that can securely store artifacts so that you can authenticate it. All right. That's something that it is a capability, not a function on everything. And virtualization. Everyone work with? Has anyone worked with a virtual OS environment?
Yes.
Yeah.
Oh, yeah.
What's the benefit of it? What good does it do?
Save space.
Allows you.
Yeah.
Okay.
Go ahead.
I wanted to say that it allows you to use one machine and many different OSs.
Yeah, and you don't have to partition the drive and boot to different ones. You can also crash one, and it doesn't matter. You can use it as this is a bad recommendation from a security perspective. You can use it as its own sandbox, and you can let it get infected, you can let it get destroyed, you can let it get hacked, and it doesn't matter because you can wipe out that whole instance of that OS and
Is that
just.
the entire purpose of them?
Yeah, that's a good suggestion. That's not a bad one at all.
It still shouldn't be on an operational machine that does have the OS that's running live on in your enterprise.
So sandbox your sandbox.
Stovepipe it. Make sure that it's air gapped from. We don't even use that term anymore, do we? Because it's wireless. Make sure it's totally away from your network.
I know what air gap is.
Huh?
I know what air gap is.
Okay. All right. Good.